Welcome. We are on page 2 of our Chapter 5 exam practice, number 5. So suppose you play a game in which you pay $2 for a spin of the spinner, which has 8 equally likely regions. And if the spinner lands on region 1, you win $5. If the spinner lands on region 2 or 3, you win a $3 gift card, and then otherwise you win nothing. And we'll be interested in the expected value for you on a spin of the spinner. All right, so let's keep track. We'll go with our money here, our net gain on a spin. So a reminder here, net. So if you play, you would take your winnings, but you'd have to subtract the cost to play the game. So you may win, but you always had to pay them money to play. All right, so if you land on region 1, you will get a $5 gift card. So there's your winnings, but you do have to deduct the $2, which was your cost to play the game. So you'll still be ahead. Your net will be $3. All right, if you land on region 2 or 3, your winnings will be a $3 gift card. And you'll take away your cost to play the game. So you'll still be up. You'll be up $1 net. All right, and then finally, the other regions, well, if you're not 1, 2, or 3, the other regions would be 4, 5, 6, 7, or 8. So if you land on any of those 5 regions, your winnings will be nothing. So those are losing regions. All right, minus, you did have to pay $2 to play. So in that case, you're going to be out your $2. So your net, you'll have a net negative, you'll be down 2. All right, and then let's talk probabilities. So probabilities are based on the likelihood of landing on these particular regions. So because there's 8 regions, I'm just going to put my denominator down. So we know that the denominator is 8 because of 8 regions. And we know that there's one region 1. So one region wins you the $5 gift card. Regions 2 or 3. So 2 regions win you that $3 gift card. And then the remaining 5 regions, so 5 out of those 8 are the losing regions. All right, and you can always check your numerators, make sure that they add up to 8, so you know you've accounted for the whole spinner. So 1 region plus 2 regions plus 5 regions gets you all 8 regions. All right, so we're good with our table, and then we're ready for expected value. All right, so the expected value of X, so it represents a long-term average. So what we're looking for is if you play the game over and over and over again, what can you expect per game to be your average winnings or losings, which we'll find out. So expected value of a random variable X is the sum, capital sigma, and we'll be adding the product of X and its corresponding probability. All right, and I'm going to write the pairs in parentheses so we can see them. So we'll take our $3 net. I'm not going to write the units now. We'll take our $3 net. That happens 1 out of 8 times, plus my $1 net. That probability was 2 out of 8, plus my final pair, -2 net, and that probability was 5 out of 8. Okay. So sometimes in class, I'll show some fraction work here, but I'm just going to go straight to the final answer by entering that entire expression there, just like I wrote it on my calculator. So I'm going to open the parenthesis here and just type 3 times 1 divided by 8, close parenthesis, plus the next pair, 1 times 2 divided by 8, plus my last pair, -2. So my negation button, -2 times that probability, 5 divided by 8. All right, so you can always just enter it like that. And that is coming out to be negative 0.625. I'm going to put the units back in now so that we can interpret that. All right, so if you played this game repeatedly, so in the long run, you should expect, so your net is negative, so I'm expecting to lose. So on average, every time you play, you're going to expect to lose $0.625 per play. So remember, don't say negative again. You've already indicated your loss. I'm going to lose. So units are dollars, $0.625 per play. So I know that amount of money looks a little bit strange. So I'm just going to write it in cents as well. So that would be 62.5 cents, right? 62.5 cents per play. So the idea is if you play, sometimes you'll win $5, sometimes you'll win $3. But most of the time, 5 out of 8 times, you are going to be losing money. So in the end, if you continue to play this game, you'll be losing on average 62.5 cents per spin. All right, let's do another one similar, but this one is going to be about basically a raffle ticket. So in this case, it is a charity running an auction, and they're going to sell 500 tickets at $1 each. They'll give away one prize valued at $100, one prize valued at $50, 3 prizes valued at $10. And we'd like to know the expected value if you buy a ticket. All right, so in this case, I wrote lose first. We could write these in any order, but I've got my, you might lose, or you could win that 100 or the 50 or one of those 3 prizes that are $10. So let me go with the money here again first. So net gain, if you buy a ticket, you'll keep track of your winnings, but you do have to deduct the cost of your ticket. And in this case, the cost of that ticket was $1. All right, so if you lose, then your winnings are nothing, right? So you're not going to win anything, but you did buy your ticket, so you did pay $1 for the ticket, so you're going to lose your $1. So your net is negative. And then if you win $100, great. You paid $1 for that ticket, so your net, you'll be up $99. All right, you could win $50, paid $1 for your ticket, you'll be up $49 net. And then finally, you could win one of the $10 prizes minus the cost of your ticket, and that will leave you with a net of $9. All right, and then we can take care of the probabilities. All right, so they're selling 500 tickets. So I know for the probabilities, my denominator will be 500. So just like the slices on the spinner, the total showed you your denominator was 8. Now a total number of tickets will give us our denominator. All right, so instead of starting with lose here, let me start with the information they gave you directly. So they're going to give one prize at $100. So one out of those 500 tickets will be the $100 winner. They gave away one prize at $50. So one ticket out of 500 will win you $50. And then 3 tickets out of the 500 will win you a $10 gift certificate or prize. All right, so I do have to return to then chances of losing. So let me just keep track here. I've got winners, number of winners. So one person wins $100. One person would win $50. 3 people would win $10. So it looks like I've got 5 winning tickets. All right, but they're selling 500 tickets. So if you take those 500 tickets and take away the 5 people that win, so 500 minus 5 will tell me that the other 495 tickets are losing tickets. So that part you have to give a little bit of thought here. Keep track of your winners and then take the total minus the winners to get the losing, and that will give you your probability of getting a losing ticket. And again, I'll remind you, if you want to check that you did that column correctly, those numerators added together are going to have to be 500. All right. And then we're ready for expected value. So the expected value of a ticket, so we'll take the sum, capital sigma, of each product X times its corresponding probability. And I'm going to, again, just put these pairs in parentheses so you can see them. So the first X there, -1 times 495 over 500, plus my next pair, $99 times its probability, 1 over 500, plus next pair, $49 times its probability, 1 over 500. And finally, my last pair, $9 times its probability. Oops, sorry. All right. And then you are welcome to just enter all of that on your calculator directly. So I'm going to enter it just like it appears. So I opened my parenthesis and I'm doing -1 times 495 divided by 500, close parenthesis, plus 99 times 1 over 500, plus 49 times 1 over 500, and finally plus 9 times 3 over 500. All right, I'm getting negative 0.64. And that, again, we're going to get those units back, represents dollars. All right, so what this tells me is that if they ran this auction and you played it over and over and over again, so if you did buy tickets repeatedly, just as a note here, most of the time you're going to lose your money 495 times out of 500. Occasionally you would win a cash prize and come out ahead, but it doesn't happen often. So in the end, on average, because the expected value is negative, I know that on average, I'm going to be losing on average 64 cents, or so in dollars here, $0.64 per ticket. And again, it's 64 cents, but we'll just leave the units here as dollars. All right. So that takes care of an auction or raffle type question, along with a spinner type question.